ABS on an unenclosed printer, polypropylene without special equipment, and ASA with a peel-off layer from PLA to reduce warping. These are just a few of the exciting 3D printing tricks that I'll show you in this video. With clever combinations, almost any filament can be printed energy efficiently on standard surfaces without warping. And the best part is that you don't even need a multi-material printer for this. You can change filaments manually with a simple G-code command, which I'll show you in this video. So stay tuned here at JanTec Engineering. If you've seen my video about material combinations, you may remember that ABS and PLA can be combined well. This led to the idea of printing ABS parts onto a thin layer of PLA to reduce bed adhesion and warping issues. This worked surprisingly well. I received many comments with feedback and further questions, which was very encouraging and motivating. So I did further tests and tried out additional materials such as ASA, PP and TPU. The basic idea is to find two materials that adhere well to each other, which means that they are compatible and where one adheres better to common printing surfaces than the other. There are plenty of materials that don't adhere well to most print bed surfaces like PEI. On the other hand, some materials adhere too well, which can quickly lead to a destroyed printing plate. In this case, it can also make sense to print a first layer from a material such as PLA to ensure that the component can be easily removed after printing. I will now go over the results of my experiments, showing you what worked well and what did not. I will also explain you how to use this trick on almost any 3D printer in a small tutorial. With a manual color change, you don't even need a multi-tool printer. In the past, I've found that TPU often adheres either too poorly or too well to various print beds. While it quickly comes off the Prusa satin sheet during printing, TPU adheres far too well to smooth PEI and is very difficult to remove. I have destroyed one or two sheets this way. Although this can be avoided with a little glue stick, it's still not ideal. Since my tests had shown that TPU adheres very well to both PLA and PETG, I thought that printing TPU on a thin layer of PLA or PETG might work well. Hendrik from the Electroplating 3D Prints channel had the idea of making the bottom layer peelable to get a part made of 100% TPU. So I quickly designed this test piece, which comes with a 0.4mm thin layer with a peel-off label. I then printed these from TPU, one with two layers of PLA and one with PETG as a base. As usual, the print stuck very well to the printing plate in both cases and was easy to remove afterwards. Unfortunately, both materials adhere too well to the TPU and the bottom layer cannot be easily peeled off. However, sanding or heat might work. That said, I still think this trick is very helpful for functional parts. These feet, for example, do not need to be elastic on the underside where they are mounted. So I printed them hassle-free with two base layers of PETG on a satin sheet. Again, I had very good bed adhesion and all the parts came off easily after the bed cooled. In the meantime, I've moved to Darmstadt with some of my 3D printers. Here I rent part of the industrial hall from JanTec, a filament recycling startup. When I eagerly wanted to set up my 3D printers for further tests, I realized that there were only very wobbly old tables in the hall. As I needed a stable base for working and printing, I got myself a FlexiSpot E7plus premium standing desk. The table offers a large surface to work on, while also being so sturdy that a 3D printer can print on it without any problems. During printing, I can observe the process from all perspectives, above, below and from the side, while maintaining stability, which is very useful for my research. In fact, I found myself working in standing position most of the time simply because it's so much better for my back. Thanks to the wide range of add-ons, my workflow is so much better now because I always have all the important tools at hand in the underdesk drawer. I can adjust my monitor as I like thanks to the stable arm, while also having a very clean cable management. I can now understand why FlexiSpot standing desks are so popular right now, and I honestly recommend them too. Next, I will definitely replace this old chair with a C7 ergonomic office chair from FlexiSpot, that's for sure. Check out their E7plus standing desk and ergonomic chair at flexispot.com and use my promo code YTE7P50 for $50 off on their E7 Pro standing desk. At my new workplace, I continued the ABS on PLA tests and, in particular, tested printing larger components on my Caribou MK3S. In my last video, I combined Prusameters PLA with Nobufill ABS-X and achieved surprisingly good results. The warping effect on this test model from Extrudem was significantly reduced by a layer of PLA. After the video, I received a lot of feedback in the comments. On the one hand, I often read that the trick worked just as well as it did for me, even though some of you used multiple layers of PLA. That made me very happy. At the same time, there were also some more critical comments which expressed concerns, especially regarding larger prints, and here I also have to agree with you. To dive deeper into the topic, we should first distinguish between warping and bed adhesion issues. Warping occurs when the printed material shrinks during cooling, causing parts of the objects to detach from the printing plate or bend. For example, ABS can shrink by about 1%, which can lead to internal stresses and significant warping at the edges, especially in larger components. Bed adhesion problems generally arise when the filament simply does not adhere well to the print bed surface. An example would be printing POM or PP filament on a PI sheet. It simply does not stick and the first layer would already peel off. So I experimented more and printed additional, even larger components. The method worked really well for smaller components, also with filaments from different manufacturers. However, I still had some warping with large area components and sometimes I had to abort the prints. In addition, I also tried to remove the PLA layer here to obtain a pure ABS component. Unfortunately, this was not so easy. PLA and ABS bond too well. However, it turned out that PLA can be removed relatively easily from ASA, which I will show you in a moment when we get to my tests with ASA. My conclusion is that for smaller components, this trick works very well and reliable. For large prints, you probably can't avoid the heated printed bed and enclosure because the warping forces are simply too strong. Nevertheless, there are more exciting ideas, such as printing parts of the infill out of PLA to relieve tension in the component. That's why I still see a lot of potential for further experiments and development in this area. Now a brief explanation on how to use the method I just described. With multi-tool printers such as the Prusa XL or multiplexing system like MMU or AMS, it's very simple. After slicing, simply move the slider up until the change should happen. Then right-click on the plus and select the desired extruder under Change Extruder. If you don't have this function with other printers, or if you need more freedom, it can be helpful if the part consists of several components. To do this, the object must be cut into two parts. This can be done using the cutting tool shortcut C. Any cutting position in the Z direction can be specified here. Simply enter the number of the desired layers multiplied by the used layer height. In my case, with 2 layers and a layer height of 0.2 mm, this is 0.4 mm. Then select Cut into Parts and click on Perform Cut. The object now consists of 2 parts for which we can select different materials and settings. If the print bed temperatures of the materials differ, we have to use a simple trick and just set the print bed temperature and the filament profiles to the same value. For ABS on PLA, simply enter 60 degrees C bed temp in both profiles. For a regular printer with only one nozzle and no multicolor system, we have to use a custom G-code. I'll show the whole thing in the Prusa slicer for the MK4, but it should also work the same way for other printers in similar slicers like Orca or Bamboo Studio. To do this, you first slice the model as usual with PLA filament profile. Then move the slider to the desired position where you want to change the filament. Right-click on the plus again and select the option Add Custom G-code. We now write M600 for the filament change and M109S for adjusting the nozzle temperature. After the S comes the target nozzle temperature. For ABS, this would be 250 degrees Celsius, for example. I've had the best experience with this G-code though, which is only slightly longer. M104 is basically a non-blocking instruction and increases the temperature without waiting. This speeds up the whole process and makes sure the nozzle is hot enough to purge ABS. This should work with all current Marlin-based printers. For Clipper, I recommend downloading appropriate macro configs to use M600. Feel free to share your experience in the comments. Now let's move on to other filament combinations. Under my last video, many of you commented that they'd like to see a test with ASA. So I loaded Prusamet ASA Natural and PLA Galaxy Black into my Prusa XL and printed this handle for 2020 profiles. The first 3 layers are PLA, the rest is ASA. As always, I kept the print bed permanently heated to 60 degrees C. You can also see a control measurement here. The print worked very well and I couldn't detect any warping. The layer adhesion in the ASA part is also quite good. I noticed on the purge tower that the ASA lines didn't adhere so well to the PLA. That's why I thought that the tear-off ledge I tried with TPU could be a worthwhile experiment. So I designed a separate label that can now be connected to any 3D model in the slicer. The first test print actually worked exactly as it should. Although the prints stuck together, the PLA layer peeled off perfectly from the component. In the first attempt, I only selected 3 solid base layers, which is why the infill forms the bottom layer here. That's why I printed the part again with 5 bottom layers. Here is the removal of the PLA layer with sound on. So I'm now holding a perfect ASA part in my hand, printed on an open printer in a cold workshop and just 60 degrees C bed. I have to say that I was very impressed by this result. All in all, I can say that the combination of ASA and PLA works in a similar way to ABS, except that the layer can be removed afterwards. Anyone who has ever worked with polypropylene, PP for short, will know that it adheres very poorly to standard printing beds. I once tested this print sheet from PP Print, which was specifically developed for PP and worked well. However, if you don't want to invest in such special accessories, a filament combination can be interesting. The first thing I tried was PP on PLA. This didn't work out at all from the start. PP simply doesn't stick to PLA and I had to stop printing after a short time. However, PP on PETG turned out differently. The materials adhered relatively well to each other. Over time, the corners of this test print became slightly loose, but the print was still successful. I wouldn't recommend PP on PETG for larger parts, but it can definitely be worth a try for small prints, especially if you don't have the right equipment at hand. It also gave me the idea that PETG could be a good support material for PP. In my experience, it is very difficult to get the supports off. PETG could adhere just well enough to support overhangs and be easily removed afterwards, similar to PLA with PETG. I also plan to investigate this in a future video using tensile testing. I really hope you enjoyed this video and were able to pick up a few tips. That was by far not all, and I'm already working on further exciting printer improvements, so feel free to subscribe to my channel. Thanks to my first channel member, TechGeek10, you are amazing. Now you can also watch my video about filament combinations, in which I show other applications such as PETG with PLA support structures or various prints that combine a soft TPU with a stiff PLA or PETG. Thanks for watching and see you next time here at JanTec Engineering.